Now we're going to deal with for loops in a more complicated situation. Consider the following. I have a list items, and it contains a list of colors. Suppose that in my output I would like to not only put the colors, but to number them. Red is the first one, up through green is the fourth one. Think about this. If we only want to print out the colors, this is easy. That's doing the same thing. Print the color for each element of the list. So here we could have very simple code with the for each loop. But the more elaborate version has this number that's changing. So it makes sense to have a variable, which I'll call number. And the general pattern is we want to print out a number and the item. Well, let's think how we can go about that. Let's do this in steps. We're not going to completely get it right the first time. Here's one version. This is number entries 1, where I set the value of number initially here to 1, and then I have the loop and I print out the number. We can run this thing. It's not going to work correctly, but it's a start. And so I get the right format with numbers in the beginning. However, of course, I just set the number to 1 and never changed it. It's going to be 1 all the way through. That's not certainly what we want to end up with. The second time through, we want it to be 2. Well, here's another variation. If we want, for the second time through, for the number to be 2, when we get to the bottom of the first loop, hey, we can change the number to 2. Let's see how this works. We're closer. We were initially 1. At the bottom of the loop, we changed number to 2. This worked perfectly. Unfortunately, we were still setting number to 2 when we wanted 3 and 4. We need a more general way to change the value of number. Just setting it to 2 doesn't work all the time. So we need some code that will work whenever we want to go from 1 to 2, or 2 to 3, or 3 to 4. And we're basically just counting. We count by adding 1 each time. Here is a version that will actually work. Again, we initialize the number to 1 and print. But here we have a more general piece of code for changing it to the next one. We have the old value of number. We add 1 and make the new value of number that will be correct for the next time through the loop. Let's just test that this works. There we are. Now they're numbered in order. Not only do we get the 1, but the same rule will allow us to make the 3 and the 4 correctly. I'm back in the tutorial. I've superimposed a copy of the code here with the lines numbered. Following the sequence in this successive modification loop is central to understanding what's going on. We will use these ideas over and over. A way to reinforce this is to play computer. I have a table here that corresponds to playing computer, and let's just go through it and make sure we see what's happening. I have the line numbers here. Item, of course, the current item in the list is of something that changes, and number is the thing we've been working on changing, and my usual comment. The list doesn't change. I don't bother to put it in the table directly here. Here's the list. So the first line sets the list. The second line sets number. Here we are. We go on sequentially at this point still to the third line, which is the for loop. The first time we hit it, it sets item to the first value in the list, so we get red here. Number is still 1. After the heading, we go on sequentially for a while through the loop. Line 4 prints out the first data that we want, when the item is red and the number is 1. The next line sets us up. We use the current value of the number, add 1, and now the new value of the number is 2. We're at the bottom of the loop, the end of our indentation. For the for loop, we go back to the heading, change item to the next element, orange, and go on through the loop sequentially. First, we print the data that we want. It's now 2 and orange. Then we change the number that was 2 here, adding 1 to make it 3 after this statement. Again, we're at the bottom of the loop, so we go back to the heading. Item now becomes the next element, which is yellow. Here we have it. We go sequentially through the loop. The next line prints out what we've got so far. The value of number was 3, item was yellow. Line 5 then takes the current version of number, adds 1, and gives us the 4. Again, we're at the bottom of the loop here, so we go back to the heading. Item is now the next element in the loop, with the last element, in this case, green. Here it's set. We go on through the loop, now sequentially for a while. We print the current data. We got 4 and green. And then we advance the number in line 5 by 1. It was 4. It becomes 5. Now, we're not actually going to use this, but it doesn't hurt, and it makes the whole loop structure work. Because as we see, now that we're at the bottom of the loop, we go back to the top, and we look for another element. There isn't any, so we're done with the loop. This loop illustrated several things I want to emphasize. First of all, we saw that we could be varying not one, but several variables. And of course, our initial way of changing a variable in a for loop was just the variable that corresponded to the next item in the list. But we also see that we can have variables that we also set separately, initializing before the loop, and then updating within the loop so that they're correct for the next time we want to use them. This modifies this other variable, for instance, number here, each time through the loop, and I call this then a successive modification loop. This follows a very general pattern which I outline here. This is a pseudocode outline, a mixture of English and Python ideas here. We need to initialize the variables to be modified that aren't set automatically, like the item. Then we have our loop heading that controls the repetition. Within the loop, we generally want to do something in particular, like print something out, as we were doing. But the trick here is that since we're going to be repeating this code, we want, unless it's going to be an exact repetition, the contents that we're referring to have to change. So while we need to modify anything to be ready for the next time through the loop, as we do here. And that's a general feature that we're going to see in these successive modification loops. If you compare this pattern to the previous ones we've looked at with for loops, then notice the difference is how we're handling in the number of variables. Our original for each loop just needed to mess with the variable that was associated with the individual items in the loop, which we used each time. The simple repeat loop didn't even need to use the variable that went through the list. And then we have our successive modification loop that needs not only the variable that goes through the items in the list here, but it also needs other variables that we have to successively modify. I've gone on in idle to another version of this program. This idea of numbering a list is a unified idea and possibly reusable, not just for that particular list of colors, so it makes sense to put it in a function. So now the list items is a parameter, and then the body of the code here is the same that we had before. The advantage of putting it under the name number list as a function is that we can, of course, use it with the exact same data that we had originally, here are the colors, but now we can use this function with any old list, like this list of fruits. Let's test this. And there we have it. We got the colors listed just as we had before, but now this list that we never considered before at all still works. We can number the fruits. The flow of control is the most elaborate yet in this program. Let's make sure we understand it. The way this is set up, we have two definitions that the computer remembers. This is the only line directly executed, and it calls the main program. So now we go back to here and run these lines. But first, the first line is the function call to number list. So we go up to here and start running through number list. And now we've got another way to rearrange our order of execution. We hit the for loop, and of course we go through this over and over. And until when we're finally done, we're at the end of the function. We go back where it was called. We go on to the next line, print an empty line, go on to the next line, and then again we have another function call with a different value for the parameter this time. We go back and execute this code with the new value of the list, and again we work through in order until we hit a for loop, which again changes the order of execution, making us loop through this until we're finished with the list. And when we're done with the for loop, there's nothing else in the function, so we come back after the function, and that is also the end of the main program. So we go back where the main program was called, and finally we're done.